Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.10. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.10. Find the value of voltage V0 in given below figure using nodal analysis. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 1 kilo ohm resistance labeled as V0. So without wasting time, let's proceed towards the solution. So before applying the nodal analysis, we have to follow some steps. The first step is to label all node voltages. In this case, these nodes are labeled as V1, V2 and V3. Now in this circuit, if we observe, there is a voltage source that exists between two non-reference nodes. So we cannot solve this problem using simple nodal analysis technique. In order to solve this problem, we have to make a super node on this point by merging this voltage source either to this node or this node. And for the merging of this voltage source to its adjacent node voltage, we have to follow super node technique. Before applying supernode analysis technique, first we have to learn the concept of supernode analysis. If you already know its concept, you may skip this part of the video. Here I am taking a reference circuit diagram for the understanding of supernode analysis concept. In order to apply supernode analysis technique, we have to remember a solid key point. If a voltage source exists between two non-reference nodes, then supernode analysis technique will be applied to solve that problem. And in order to apply supernode analysis technique, we have to merge that voltage source to any one of its adjacent node voltages. Whenever we will merge voltage source to its adjacent any node voltage, that node will act as supernode. Now we will learn about how the voltage source is merged to its corresponding node voltage. For better understanding, we will take this part of the circuit in order to form a supernode. Here a 12 volt source exists between two non-reference nodes. Now as we are dealing in simple nodal analysis technique, voltage across any element between two nodes is always equal to the difference of those two node voltages. In this case, voltage across this voltage source is 12 volt, which is indicating that the potential difference of these two node voltages is 12 volt. So we can write this statement in mathematical form. Potential difference of these two node voltages is equal to 12 volt. We will consider both cases, and in both cases the voltage equations will be same. In first case, we are considering voltage V2 is on higher potential than voltage V3. So the direction of current will be from V2 to V3. V2 minus V3 will be equal to minus 12 volt. Here the direction of current is from this node to this node and current is entering from negative terminal. That's why this 12 volt is taken with negative sign. Now if we want to merge the value of this voltage source towards this node V2, then using this equation, the equation of voltage for V2 will be equal to V3 minus 12 volt. Similarly, if we want to merge this voltage source towards V3, so using this equation again, the equation for this node voltage V3 will be equal to V2 plus 12 volt. Now we will consider another case where voltage on V3 is on higher potential than voltage V2. In this case, voltage difference between these two node voltages will be equal to V3 minus V2 equal to plus 12 volt. Here V3 is on higher potential than V2. It means the direction of current is from V3 to V2 and the current entering terminal is positive. That's why this 12 volt is taken with positive sign. Now using this equation we can merge this voltage source either to V3 or V2. If we merge the value of this voltage source to node V3, then using this equation V3 will be equal to V2 plus 12 volt. Similarly, if we merge this voltage source into node V2, then V2 using this equation will be equal to V3 minus 12 volt. You may see that in both cases the equations for V3 and V2 are same. After calculating node voltage equations including voltage source value, we can form supernode on these 2 points. In this first diagram, 12 volt source is merged with V3 and V3 is replaced with its equation V2 plus 12 volt. Similarly, in this second diagram, 12 volt source is merged with V2 and V2 is replaced with V3 minus 12 volt. After merging the voltage source to either node, this node will act as supernode and it will be considered a single node inside the network. Now move back towards the problem. Potential difference between these two node voltages is 12 volt, and because we are considering V1 is on higher potential than V2, so the direction of current will be from V1 to V2. So according to the direction of current entering terminal will be negative. That's why 12 volt is taken with negative sign. Now we want to merge 12 volt source to this node voltage V2. In this case, using this equation, V2 will be equal to V1 plus 12 volt. So we can modify the network by merging this voltage source to node V2 and replacing V2 with V1 plus 12 volt. Now this node will act as a supernode and it will be considered a single node inside this network. At this stage we can apply nodal analysis on this network to further solve this problem. Now we will assume and label all unknown branch currents along with their directions. In this case, currents through these three branches are labeled as I1, I2 and I3, and all of these currents are leaving from non-reference nodes. Similarly, current through this branch is I4 and it is leaving from this node and entering towards V3 node. Now inside this network there are two number of non-reference nodes. One node is this and other one is V3. So there will be two node voltage equations for this network. We will start applying Kirchoff's current law on this node to write its node voltage equation. On this node, one current is entering, that is 8 milliampere, while rest of all currents are leaving from this node. Entering current is taken with positive sign while leaving currents are taken with negative sign. Now we have to replace these currents with their respective equations. Current I1 will be equal to voltage across this 3 kilo ohm resistance V1 divided by the value of resistance 3 kilo ohm. Similarly, current I2 will be equal to V1 plus 12 volt that is appearing across this 6 kilo ohm resistance divided by the value of resistance 6 kilo ohm. Current I4 is leaving from this node. It means this node voltage will be considered as higher than this node voltage. So the potential difference between these two node voltages divided by the value of resistance will be equal to I4. I4 is equal to V1 plus 12 volt minus V3 divided by 2 kilo ohm. Now in order to omit all denominator values, we will multiply this equation on both sides with 6 kilo ohm. Product of 6 milliampere and 6 kilo ohm will result 36 volt. Milli will cancel out with kilo. Here product of 6 kilo ohm will cancel out with 3 kilo ohm, only 2 will left and that 2 will be multiplied with V1, it will become 2V1. Similarly, 6 kilo ohm in denominator will cancel out with the product of 6 kilo ohm, only V1 plus 12 will left and both of these will be multiplied with minus outside, it will become minus V1 minus 12 volt. Here product of 6 kilo ohm will cancel out with 2 kilo ohm in denominator, only 3 will left, that 3 will be multiplied with minus, it will become minus 3, and this minus 3 will be multiplied with V1, it will become minus 3V1 minus 36 volt and plus 3V3. Now add constants together, minus 36 volt and plus 36 volt will cancel out with each other, only minus 12 will left. Here minus V1 minus 2V1 and minus 3V1 will become minus 6V1. So the equation will become minus 6V1 plus 3V3 minus 12 equal to 0. Now place this minus 12 volt on other hand side of equal. The equation will become minus 6V1 plus 3V3 equal to 12 volt. And this equation will be labeled as equation A. It is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this node. At this node, two currents are entering, 2 mA and I4, while only one current is leaving, that is I3, and leaving current is taken with negative sign. And next step is to replace these two currents with their corresponding equations. Current I4 is equal to V1 plus 12 volt minus V3 divided by 2 kilo ohm, and current I3 will be equal to voltage across this 1 kilo ohm resistance, that is V3, divided by the value of resistance 1 kilo ohm. Now in order to solve this equation, we will multiply this equation on both sides with 2 kilo ohm in order to omit all denominator values. Product of 2 kilo ohm and 2 milliampere will result 4 volt, milli will cancel out with kilo. Here product of 2 kilo ohm will cancel out with 2 kilo ohm in denominator, only V1 plus 12 volt minus V3 will left. And here product of 2 kilo ohm will cancel out with 1 kilo ohm in denominator, only 2 will left, and that 2 will be multiplied with V3, it will become minus 2V3. Now solve this equation, add 12 volt and 4 volt together, it will become 16 volt. Similarly, minus V3 and minus 2V3 will become minus 3V3. So the equation will become V1 plus 16 volt minus 3V3 equal to 0. Now place this 16 volt on the other hand side of equal. So the equation will become V1 minus 3V3 equal to minus 16 volt. And this equation cannot be further solved. So we will leave this equation as equation B, and it is the second node voltage equation of this network. Up to this point, we have retrieved two node voltage equations from this network. Now we will solve these equations in order to get the value of voltage V3. We are interested to calculate the value of voltage V3 because it is appearing across 1 kilo ohm resistance, while V0 is also appearing across 1 kilo ohm resistance. So indirectly voltage V3 will be equal to V0, and it is the requirement of the scenario to calculate the value of voltage V0. That's why we are focusing on this voltage. In order to get the value of voltage V3, we will multiply this equation B with 6. It will become 6V1 minus 18V3 equal to minus 96 volt. Now add equation A into this resulting equation. Minus 6V1 and plus 6V1 will cancel out with each other. Minus 18V3 plus 3V3 will become minus 15V3, and here minus 96 volt plus 12 volt will become minus 84 volt. In order to calculate the value of voltage V3, we will divide on both sides with minus 15. Value of voltage V3 will become 5.6 volt. And because V3 is equal to V0, so we can say that the value of voltage V0 inside this network is 5.6 volt. So this was learning assessment E3.10. Thank you. See you again in next video.